again. So we'll start with 3 derivatives to get us going. Okay, so not bad. Everyone called out that first one, which led to the second one, e to the sine x times cosine of x, chain rule. And then that last one threw some people off. Not all of you, though. Some of you got it. We'll start with 5 to the x squared. And then 2 things we need to include, and it doesn't matter the order. My brain thinks chain rule first, so I'd put the 2x, and then natural log 5. A few of you put those in different orders, but you're multiplying, so it doesn't matter. So those are our derivatives of powers. Now we're going to go backwards, but in some ways it's not difficult because consider the antiderivative of e to the x, which means who has a function, or who has a derivative of e to the x? E to the x. So that means the antiderivative of e to the x is e to the x. Somebody want to throw one more thing on that? Plus c. We'll often do u substitution with this as well. So antiderivative of e to the x is e to the x plus c. If we do a u substitution and we end up with a u in there, it's still the same thing. E to the u plus c. So those are the big things for today. It's another one of those days where it's like you were going to get this integral over and over and over again. The difference will be, did we understand what to make u? Okay, number 1. Oh, I can pull a popsicle stick for number 1, right? Because there's nothing crazy about number 1. Avery, what's the antiderivative of e to the x dx? E to the x plus c. Okay, but 2 and 3, we start getting a little bit weird because we got numbers in there. So, you got a u substitution for me on number 2? Let's let u be 2x. And then du is 2 dx. It's like, oh, we've played this game before, so I want du to show up. So I need a 2 on the dx and a 1/2 out front. And so now I've got 1/2 e to the u du. Well, again, we're going to hit that 10 times today, maybe. Antiderivative e to the u is e to the u. Still have that 1/2 plus c. We can leave that because we said what u is. If you want to make it look like a multiple choice answer, you can put the 2x back in there. But either one of those is equally okay, as long as you've clearly said what u is. Okay, number 4. Oh, it's a 1/2, but same type thing. I think I would show my work on this because it feels like it's a little bit different with the 1/2 out there. So 1/2 x du is 1/2 dx. So, okay, now I see how this is different. I need a 1/2 on the dx, which means what number goes out front? A 2. So 2 antiderivative e to the u du. 2 e to the u plus c. Why don't you try number 5? So a little bit different. What do you think u should be? I'll get you started. 1 minus 3x. You got antiderivative e to the u du. So negative 1/3 e to the u plus c. What about number 6? It's in the denominator. I kind of don't like that. Is there a way we could rewrite that? We could write it as e to the negative x. And then start off on our U substitution. These are pretty easy. Just let U be the exponent and then fix whatever needs to be fixed. Alright, 7 looks a little bit weird. What do you think U should be, though? Should we let U be? What's that? Something with the x squared. But, like, we want the antiderivative of e to the u to show up. So let's just make u be this whole thing. That way we'll have antiderivative of e to the u. We'll worry about the rest as we go. Don't like 1 over x squared. So let's change that to x to the negative 2. So derivative would be negative 2x to the negative 3. Oh, that's good, right? What do I need to do to fix the rest of my integrand here? Just the negative 2, because I've already got over x cubed. So the negative 1/2 out front. And then all of this stuff put together is du. And, I've got the antiderivative of e to the u du again. So that's negative 1/2 e to the u plus c. You can leave it like that, or you can put the x stuff back in there. The repeated warning of if you're going to leave it as e to the u, you better have explicitly said what u is. How about number 8? What do you think we should do on number 8? Yeah, let's divide first. So that would be... let's pick on some people. Let's pick on 3 people, in fact. James, Jimmy, and Abby. So James, that first one, what's e to the 2x over e to the x? It would be e to the x. Jimmy, how about 2 e to the x over e to the x? 2. And Abby, 1 over e to the x? Wait, I don't want derivatives. I'm just doing algebra right now. So, what's a different way to write 1 over e to the x? I mean, it is... There we go. That way we can take an antiderivative a little bit easier. Okay, so the first one would just be e to the x. The next one would be 2x. And that last one, I bet Addie can get without going through all the u substitution. Addie, what's the antiderivative of e to the negative x? Good. Again, if you're stuck on one of those, well, take the time to say u equals negative x. Work in the process. But once you've done a bunch of these, you start doing some of the easier ones in your head. Uh-oh. Now our base is an e, so now we got that 5 in there. But this is similar to the one we did earlier. Austin, what's the derivative of 5 to the x?
Isn't it ln 5 times x, or times 1?
Okay. That's from the 5. That's the chain rule, yes. But the derivative of a power, or an exponent, is that 5 to the x. So you remember the natural log part, you remember the chain rule, but the 5 to the x part is, we got to be careful. Then how about derivative of a to the x? Okay, I like a to the x. Chain rule, what's the derivative of x? 1. But then, assuming that a is not equal to e, so assuming we have a different base down there, natural log of a. Obviously, you don't have to write the 1, but that kind of emphasizes the chain rule. So, what do we think the antiderivative of 5 to the x is? It's definitely going to have a 5 to the x in there. And there's going to be a natural log of 5 involved. And there is going to be a plus c at the end. But where do I put this natural log of 5? In the denominator. When we were taking a derivative, when we were moving forward, we multiplied. Now that we're going backwards, we're taking an antiderivative. We'll divide by natural log of 5. So take a derivative, multiply by natural log of the base, take an antiderivative, then you anti-multiply. Right? So divide. Jameson, how about the antiderivative of 7 to the x?
7 to the x over the natural log of x.
Over the natural log of what?
7.
It's 7. Justin, the antiderivative of 3 to the x?
I'm going to say 3 to the x over the natural log of 3.
That would be right. Oh, I made a small mistake, although I guess maybe it's a major mistake. I don't know. On all 3 of those, plus c. Some of you had said plus c early on, and I didn't write it down. So now we get to go big picture here and just say, Autumn, the antiderivative of a to the x? How about look at those previous 3 and look at who's playing the role of a here. There we go. A to the x over natural log a plus c. Jace, it's almost the same question, but there's u's in there. So what's the antiderivative of a to the u du?
A to the u, then over ln a plus c.
Yes. All right, well, number 1 doesn't even need a u substitution. So, Kenneth, how about number 1? What's the antiderivative of 2 to the x dx?
2 to the x over natural log of 2 plus c.
Good. All right, number 2, a little bit different. Ambria, let's do a u substitution on this one. What do you think u should be? 4x. That way we'll have an antiderivative of 9 to the u. But now we've got to piece together the rest of this thing. So Bailey, if u is 4x, then what's du?
4 dx.
So what does that mean in terms of my integrand? Good. So 1/4 out front. We let 4x be u, and then 4 dx put together is du. And the antiderivative of 9 to the u is 9 to the u over natural log 9. We still have a 1/4 out there. Plus c. And again, you can plug the 4x in or not, whichever. Alright, why don't you try number 3? Do you need a hint for what u should be, or are we okay there? As always, if you pick your u correctly, things get much easier, much quicker. Luke, how about the antiderivative of 2 to the u du?
2 to the u over ln2?
Yes.
Plus c.
Plus c. And as always, if you've clearly defined what u is, you can leave it like that. Most of the time you will have said what u is. As you get further, sometimes you'll start doing some of this stuff in your head, which is fine, but if you do this stuff in your head and you don't write what u is, then this answer is not okay, because I don't know what u is. Obviously, I'm going to guess. It's not my job to guess. It's your job to tell me what u is. Yes, sir.
Where does the ln2 come from?
Because, think of it this way, when we took a derivative, separate problem. If we take the derivative of 2 to the x, that's 2 to the x times natural log of 2.
Oh, yeah.
So if we're going backwards, we're going to underivative. We still get 2 to the x, but now that natural log of 2 goes in the denominator. So derivatives, moving forward, we multiply. Underderivatives, we're moving backwards, so we divide. Number 4 looks wrong. Looks not wrong. Looks like it needs to be fixed. Caden, thoughts on number 4?
Could it be 5 to the negative 2x?
Yeah, let's reshuffle that into 5 to the negative 2x dx. And then again, if you're confident, you might be able to jump to the answer from there, because you're off by negative 2, so what would that mean? I don't know. I'm always worried I'm going to get it backwards, so I'm going to take the time to write out u equals negative 2x. du is negative 2x. So negative 1/2 antiderivative 5 to the u. You can maybe do it in your head, but it's probably worth it to write it out. Kelsey, what's the antiderivative of 5 to the u?
5 to the u over 5.
Good. You want to say anything else on that, Kelsey? Plus c. And again, I've said what u is, so I can leave that as my answer. Takwa? The multiple choice answer for this, you want to guess what it would be? We're almost there.
I want to say -1/2, and then we would move the 5 -2x down to the denominator.
Oh, I didn't even think about that. They might. Yeah, you're right. So it might look like that. But you're right. They could, that 5 to the negative 2x, they could put that in the bottom. So yeah, that's a good question. I don't know. It could be either one of those. All of those are okay. Well, the first one wouldn't be a multiple choice answer because they wouldn't have told you what u is, but either of those would be okay. I suppose you could get, no, that wouldn't be right. Never mind. So you could use that negative, but no, I don't do that. Okay, good question. So that's it for today. I don't want to make it sound like it's easy, but the next worksheet in the packet is worksheet number 4. Thank you. And we will have 2 days to work on it, so if you want to say today is odds and tomorrow is evens, so split it up a little bit, that's fine. Or you just want to do a few of them tonight and ask me questions tomorrow.